Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 2 from the February-March 2020 International GCSE Cambridge Paper 4 Variant 2. This is the 0580 syllabus, and this question here is all about graphs of functions. Now, in this question, we have a function which is y equals 2x cubed minus 4x squared plus 3. And we have a table of values in which some of the values are not there. Right? There are a number of ways you can go about filling in the table. You could just in your head put in these values. I mean, for the first one, it's not a problem at all. When you put 0 into this function instead of x, you have to substitute x instead of this number instead of x in the function given. So you're going to have 2 times 0 cubed minus 4 times 0 squared. All of that will be 0 plus 3. So that, of course, we're going to end up with 3 here. You're going to put 0.5 in there. You could do it in your head, or you could resort to your calculator. Okay, and for your calculator, you can set it up in such a way that you can replace values in there. So you have 2 times, and you've got 0.5 cubed, which is, can you use this button there, minus 4 times 0.5, and then you're going to put squared there, and then plus 3, and that should give you your answer, which is 9 over 4, which is 2.25. 2.25. If you want to make sure, in case you have made a mistake, for example, you could replace the 0.5 with minus 1 and see if your calculator will still give you the correct answer. Oops, what have I done? So you could replace the 0.5 with, for example, -1 in these two places. And you can check to see, if you want to make sure, you can check to see if you still get the correct answer. So you can check with the table, does it give you what they have there? Yes. So you know that you've put the right, things in the right way in your calculator to give you the correct answers. So now you can, for example, just get rid of the minus sign to see what happens when you put 1 in there. Okay, this one you could even do quite easily in your head anyway, but just show you, and that gives you when x is 1, y is 1, and you finish the answer. Alternatively, if you wanted to, you could set this up in basically a table. So you can say shift and so another way we can check to see if the table is correct, as I was mentioning, is you can basically use the table function, which if you, let's do this again. If you go to menu and you go down to the table function, which is this number 9, you can press 9 here. You put in the function, so you say 2, and the x is here, 2x and cubed, which is this button over there, 2x cubed, minus 4x squared, so 4x squared, and then plus 3. Then you press equals again, and it will ask you if you want to put another function, which we don't, it's the only function we want to use. And then you press equals again, and then we want to start from -1, so it says table range, so we've got to put -1, -1, and the end, we want to end at the number 2, okay, we end at 2, so we press 2, press equals, then 2, then press equals, and steps where we're going up in halves. It's going from -1 to -0.5 to 0, so going up in half, so step, that means how much you're going up by. We're going up by 0.5s. And then when you press equals, it will give you a table. Okay, and you can see that this table starts from -1. You've got -1, -3, -0.5, 1.75. You can see that we're correct. 0, 3, 0.5, 2.25 we saw, and we got here 1, 1. And 1.5, 0.75, and 2, and 3. So we can see all the other values are correct. So you can then just write down the values that you have. So there's 2 ways we can deal with filling out the table. Now this one here is pretty simple to just do it either in your head or just, just put one of the values in and get it. But if there's a lot of values to fill out in a table, then this might be something that you might find more useful. Okay, so that's how we can deal with filling out the table. All right, so that's part A done. Now part B, well, 2a part 2, sorry. It says on the grid, draw the graph of y equals 2x cubed minus 4x squared plus 3 for x between minus 1 and 2. So we've got to plot these points on this grid. All the values are given to you. All the scale is already done for you. All you do is plot the points. You've got to be proficient at reading the values on graphs. So you've got -1, -3. That's not a problem. That's pretty simple to plot. It's right on the edge here, -1, -3. Now, what you don't want to do is you don't want to make like big blobs like that. Okay? Either you do a thin cross or dot and circle to show your point. Okay, I prefer to do dot and circle. Makes it much more accurate. So I'll put a little dot at that place where I want to plot the point. Okay, and then I will circle it to make it clear where it is. Okay, that's how I like to deal with it. But putting a big blob there is not good because it's not going to be very accurate. You see, when you draw through it, -0.5 and 1.75. So -0.5 is right here, and 1.75. Well, that's 1.5. Okay, you can see each one of these is 0.1, so that's 1.5, 1.6, 1.7. So 1.75 is going to be right in the middle of those two over here. So you can see that's -0.5 and 1.75. Be very careful when you got the signs here. Sometimes you might put this at -1.75 by mistake. All right, so this is -x and +y. 0.3, well, that's the y-intercept here, which is that point right there. And then you have 0.5 and 2.25. So 0.5 is over here, and 2.25, well, that's 2.1.2.25. It's right over there. And then we have 1 and 1. That's pretty simple, 1 and 1. And then we have 1.5 and 0.75. That's 1.75. Now 0.75. Okay, that's 0.5 here. Okay, so that's 0.1, that's 0.2. Okay, so it's going to be closer to 0.2. Not that easy to make it too accurate, but that's a bit higher than a half up there. Okay, that's 0.75. Sorry, what am I talking about? That's not 0.75. Yeah, that's 0.5. Okay, that's 0.5. That's 0.6, that's 0.7, that's 0.8, that's 0.75 over here. That's 0.75. Okay. 1, 1.5, and 0.75, and then 2 and 3, that's going to be up here. All right, so so as you can see that this graph is going to have this type of shape. Let me just zoom out so we can see it better. I think I need to zoom out more. Okay, so now we can see it's going to go something like this and like this. Okay, so you have 1.5 and 0.75, 1 and 1, 2.25, that's correct. So we want it to go, we know the graph is going to go up and down and up again. Okay, it's going to have this type of shape. That's how cubic curves look. Okay, so to draw this, you got to be as accurate as you can. It's not that easy on this particular app. I'll try my best. So try and keep your palm on the inside of the curve. So what I would normally do here is I would normally, when I get to this section, I would turn the page upside down and then deal with this section, because your palm on the inside of the curve makes it more accurate. So you go like this, you go down, down, through the points as best as you can, and then like this, something like that. That's not too bad. Okay, it's I think that would be quite acceptable, apart from this part here where there's like two parts to it, so you should try and avoid doing that. Okay, but that is not too bad. If I just try to fix that a bit, just get rid of these bits. Let me fix this little part here. Okay, so it's going up through there and then down. Okay, I'm just trying to fix this little section here. Okay, so it's going to go like down Okay. 2 down. Bit more rounded here it needs to be. Sorry about this. Okay. All right, so something like that should be okay. All right, that's the graph of y equals 2x cubed minus 4x squared plus 3, okay, and between minus 1 and 2. All right, so that's the graph drawn. You should have an idea, if you know what the graph looks like, if it's a cubic function, you should realize it's going to have that type of shape. So you should be looking out for that. If it's a quadratic, for example, it might have, either this shape or this shape. Cubic, it'll go this way if it's a positive x cubed, and this way if it's a negative x cubed, and so on and so forth. So you should have an idea in your mind how it should look, so that you can picture how it's going to be when you draw it. Now, use your graph to solve the equation 2x cubed minus 4x squared plus 3 equals 1.5. Now, this type of question where you have to use your graph to solve, okay, this is one where if you just write the answers down and there's no kind of like proof that you've used your graph, or if you write your answers down and the values that you write down are correct according to this equation but incorrect according to your graph, and you haven't shown how you've tried to answer the question, you will get no marks for that. Okay, so you don't just write down the correct answers by using, for example, the calculator equation function, or rearranging this and using the calculator equation function where you can solve any equation. All right, if you do that, you won't get any marks. What you want to try and do is you want to show the examiner that you know how to answer this question using the graph. All right, and how is it that we do this? Well, what we do is we take the equation, what's drawn. Okay, this is what's drawn. So we can see that what's drawn is y equals 2x cubed minus 4x squared plus 3. Exactly what that one side of the equation looks like. That's what's being drawn. Okay, so this is what's drawn. All right, and this is what we have to solve. We have to solve this. Now, what you have to do is make sure that one side of the equation that you are solving looks exactly like what's drawn. So we can see this is exactly the same as this. It looks exactly the same. If that is the case, then you draw y equals whatever's on the other side. If this was different from that, then you would change this so that it looks like that. And then whatever you did to change this, you would have to do the same thing to that side. For example, if this said plus 1 here, and you had to make it say plus 3, you'd have to add 2 to this side. Therefore, you have to add 2 to this side, and that would then become 3.5. Then you would draw the line y equals 3.5. So once that one side of the equation that you're asked to solve looks like what's drawn, you draw the line y equals whatever's on the other side on the same graph. And that's what you should try to show that you've done. So what you should do is you should draw this line y equals 1.5 on the same graph as, what's already drawn. So label it y equals 1.5. That's part of showing your steps. And then I would, in addition, also show that I am, reading off the values from the graph where the line and the curve intersect. Let me just make that a bit thinner so that it's more accurate. So you should have these lines coming down. So you're showing the examiner that you are reading the exact points where the curve and that line intersect. Okay? So you try and do it as accurate as you can. Okay? So when I write down these x values, I have solved this equation graphically. So I need to write down what these x values are, so you've got to be careful. Now think about the scaling here. That's 0, that's minus 1. Okay, that's 0.5. Okay, so that means that's negative 0.5. Okay, how much is each of these worth? Well, this is going to be 0.1, 0.2, 0.25, 0.3, 0.4, 0.5. So yeah, so every two squares looks like it is 0.1. That's right. So that's 0.5. So that will be 0.6. So that's 0.50 that's 0.5, that's 0.55, that's 0.6. So you can say 0.55 minus 0.55 should be all right. You can even say minus 0.55. Okay, you can even go a bit more, I guess, accurate than that. You can say minus 0.55 and another 5. Okay, because it's halfway between those. And here we have 0.5, that's 0.6, that's like 0.7. Okay, 0.7. Okay, so that's going to be 0.7. 0.6, 0.7. That would be 0.65. That's 0.7. It's exactly 0.7. That's fine. And then we have this one. Well, that's 1.5. That's 1.6. 1.7. That's like 1.8. That's like 1.8. Okay. Yeah, something like that. That should be fine. So there we have the 3 solutions to this equation solved graphically. Okay, so there's part 3 done. And now for part 4, it says the equation 2x cubed minus 4x squared plus 3 equals k has only one solution for x between minus 1 and 2. Write down a possible integer value of k. All right, so we've got to find an integer value, means a whole number value for k. It could be positive or negative. And it should be that basically y equals k is the line that we have to draw. So y equals something means a horizontal line should only have one solution, means it should only intersect this curve in one place. So if we draw a horizontal line, okay, and we see where does it intersect the curve in one place? Well, you can see, just like y equals 1.5, this line would cut this curve in 3 places, means there would be 3 solutions. All right. However, if we, in this point here, there's going to be 2 solutions. If we go further up, there will be 1 solution, but that's outside of our range, because if you carry this curve further, we've gone out of the range of 2. And it says between is minus 1 and 2. So although when k is greater than 3, there would be only 1 solution, but not in the range that they gave us in the question. Okay, this is between minus 1 and 2, the x values. So I can't go further than this. So I can't include any k values which are greater than 3. I can't include 4, for example, 5 or 6. Although y equals 4, 5, or 6. If k equals 4, 5, 6, any numbers like that, there will be 1 solution if there was no restriction in the x values. However, if we go down here, if we take this line down, when we go below this point here, okay, when we go below this point here, where it turns, okay, then you see there's 1 solution, all right, because it only cuts the curve in this one place, all the way down, okay, down to here. And we have to stop here again, because our domain is only from minus 1. We're only dealing with from minus 1 to 2. So any k value, any basically y value, okay, which is an integer like 3, negative 3, negative 2, negative 1, 0. Okay, 1 won't be included because, of course, there's 3 solutions. So anything like 0, negative 1, negative 2, negative 3, any of those values would produce just 1 solution. Okay, so that will be a value of k for which there will be 1 solution in this, okay, particular restricted x value region that we have here. Okay, so we can write k equals 0, negative 1, negative 2, negative 3. All right, so we could write k equals 0, or if you want, negative 1, negative 2, negative 3. All of those would be correct answers. Okay, but writing k equals 4, for example, will not be correct. Writing k equals 3 is not correct either, because it's going to have 2 solutions here. Okay, 2 separate solutions here. All right, so, you know, basically, if it said find the range of values of k for which there's only 1 solution, then you would say k is less than, okay, the value where it turns. Okay, so that's 0.5. Let's say 0.6. You can say less than 0.6. 0.55, for example. All right, something like that, or 0.65. less than that, okay? You would say that, for example, if it wasn't restricted, you would say k is less than 0.65, and also k is greater than, I think it would go slightly above 3 maybe. Yeah, it's going to go, I think 3, you could say 3 here, or slightly above 3, 3.05 or 3.1 or something like that, if it was not restricted. But here it's restricted, so you would say, if it was restricted like this, you would say k is less than 0.65, but because it's asking you for integer solutions, okay, you can put down 0 or -1 or -2 or -3. Any of those would be correct answers. All right, so I hope that's clear. That answers question number 2A, part 2. Okay, now for part B. This part of the question here, we're given a graph, we're given the drawing of the graph. It looks like some sort of a quadratic, although we can't be sure. And we are told to, on the grid, draw the tangent to the curve at x equals 1. So we're not given the equation of the curve, we're given the drawing of the curve on an accurate grid, and we're told to draw the tangent to the curve first, x equals 1. And then part 2 says, use your tangent to estimate the gradient of the curve at x equals 1. Okay? All right, so that's the first two parts of this part B. So first thing we do is draw a tangent to the curve at x equals 1. Now, when you're drawing a tangent to a curve, you're trying to draw a line which just brushes the curve at that particular point where they want without cutting through the curve. Okay? So what I would advise very strongly that you take with you to the exam a 30 centimeters clear ruler. So you have a lot of space to work with, and you place the ruler such that it just touches the curve at x equals 1. You've got enough space to put the pencil between the ruler and the curve, so the pencil will make a line which touches the curve at x equals 1. I'm going to give an example of how that's done. Now, this is, of course, I'm not using a ruler. Okay, I'm using this tool here. Now, that's an example of a tangent to the curve. Make the tangent very long. Now, what I would do before I actually draw the line is I would make sure that it's kind of like a tangent at the point x equals 1. Now, I can see that this actually is a tangent at x equals 1. All right, that is, yeah, that looks just right, okay? That's fine. So I seem to have done it fine the first time here, but you see, it just touches the curve at that point. Now, it's not going to be, no two people will probably make the same line. It'll be difficult to make them the same. They don't expect 100% accuracy, okay? It's very difficult to draw a tangent exactly, accurately, but this particular of course, when the curve is already drawn from you, you have the grid already made for you, it's a bit easier. Okay, but for example, if the curve was, let me just change it a bit so to show you what not quite right. For example, something like this. This isn't a tangent at x equals 1, as you can see very clearly. It's a tangent somewhere over here. Okay, so you have to adjust it until it becomes a tangent at x equals 1. Okay, so you want it to be a tangent at x equals 1. So you have to adjust the ruler so that it brushes at x equals 1 like I had it before. Like, for example, here, that's quite close, but you can see that this is a tangent somewhere here, which is not exactly x equals 1. Okay, so it should be such that at x equals 1 is a tangent. Okay, so you can see that that's a lot closer to being that's the tangent at x equals 1. All right. So that is the tangent that we have to draw at x equals 1. So that's part 1 done. Then part 2 says, use your tangent to estimate the gradient of the curve at x equals 1. So we can choose any 2 points on this line that we want, and the gradient of this tangent will be the same as the gradient of the curve. Okay, so the tangent is drawn to help us find the gradient of the curve, especially when we don't know its equation. All right. So we draw the tangent, we find the equation of the tangent, or we find the gradient of the tangent, and that gives us the gradient of the curve. So what we can do is we can choose 2 points. Now, it seems to be going exactly through this point, -2, okay, 0, -2. This is the x-coordinate of this point over here. It seems to be going exactly through that. So that's 1 point on the line. I'm going to write that 0, -2. And we could even choose this point if we want. This is 1, 1. We can choose any other point we want. For example, I think this is the point it's going through almost exactly. it looks like each of these 0.1, 0.2, 0.3, 0.4. So we could use this point as 0.40. Okay, I could use these 2 points and I can find the gradient of this line. Okay, so the gradient of a line is given by the change in y, which is going to be, you can say 0 minus minus 2, 0 take away negative 2, over the change in x, which is 0.4 minus 0. So you end up with 2 over 0.4. Okay, so 2 divided by 0.4 gives us 5. So that's the gradient of the line using those 2 points. So now, if you had drawn your tangent slightly out within an acceptable amount, it could be that your answer might not be exactly 5. And I think the mark scheme gives between 4.6 to 5.4, something like that. It gives a range of acceptable values for the gradient. Okay, because that depends, of course, on how accurately you drew your tangent. And they don't expect perfection, so there's some margin of error. Okay, so if you see in the mark scheme something like this, where there's a range of values, then what's exactly halfway is the accurate value. But they don't expect you to get the accurate value. You know, it's not that easy to do. So it's no problem if your answer is within that acceptable range for the tangent of the curve. Okay, so this is the gradient, which is 5. Then it says write down the equation of your tangent in the form y equals mx plus c. So y equals mx plus c is the form for the equation of a straight line, where m stands for the gradient and c stands for the y-intercept. Okay, where the place where the line cuts through the y-axis. So we can see here that the gradient of this curve, is given by the tangent, or the gradient of the tangent, which is 5. So we can say m is equal to 5. And the y-intercept is the place where it crosses through the y-axis, which we actually used in our calculations, which is 0, negative 2. So c is going to be negative 2. So y is equal to 5x minus 2 is the answer. Now, if your tangent didn't pass through minus 2, pass through another value close to minus 2, then whatever value your tangent passes through should be written down as your c. And whatever value you got as your gradient should be written down as your m. Okay, so this depends on your graph. Okay, it depends on your graph. If your value was 4.7, for example, here, this would be 4.7. If this was, say, minus 1.8 or minus 2.2 or something like that, then that would be your value of your C, depending on your graph. Okay, so there's the answer to question number 2, part B. Okay, and that concludes this question. Other questions from this particular paper, this session, February, March 2020, paper 4, variant 2 can be found in the playlist that will be appearing. A link for the playlist will appear over here. A link for questions to do with graphs of functions will appear in this region over there from IGCSE work, and you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.